In 2035, an entire city rose on Mars, and not a single human being ever set foot on that red soil to build it. This wasn't just an emergency base or a temporary module. A fully functional underground city with streets, agricultural fields, breathable air, and running water, built from scratch by autonomous machines in less than a year. What you're about to learn is the story of how all of this became possible. It all started with a single spacecraft, one quiet landing point on a dead planet. But that ship wasn't carrying colonists. It was carrying the seed of civilization. Every compartment, every system, every device was aimed at a single goal: making Mars habitable for human beings. The first question was brutal in its simplicity. How do you power all of this? Before anything could be built, energy was needed. And the first worker to step onto the Martian surface wasn't human. It was an autonomous rover, compact and silent, with a clear mission: build the base's first electrical grid. The solution chosen for this first phase was solar power. Not rigid panels, too heavy to transport in sufficient quantities, but flexible thin-film photovoltaic modules rolled up like carpets inside the spacecraft and deployed directly onto the Martian dust. Two rovers working in sync tossed connecting cables between each other to establish the necessary connections and kick off the mass deployment process. The operation looked like a mechanical dance of precision, calculated down to the smallest detail. As the days went on, more and more rovers were deployed. A group of 10 machines kept expanding the solar field and anchoring the panels into the ground so they could withstand the Martian wind, thin but surprisingly powerful. The result was a solar power plant spanning several hectares, built entirely by robots in less than a week. Enough energy to power a small city, a remarkable engineering achievement for the first phase of construction. However, there was a problem that even the largest number of solar panels couldn't solve on its own: Mars's global dust storms. Capable of blocking sunlight for weeks at a time, these storms posed an existential threat to any base that was completely dependent on solar energy. A long-term solution had to be found. That solution arrived with the second spacecraft. At the heart of that cargo was the core of a permanent power plant, a compact nuclear fission reactor. Not the complex water-cooled type that usually comes to mind when people talk about nuclear energy. This was a solid-state uranium design, using heat pipes to transfer large amounts of heat away from the reactor core. That heat then powered the Starlink engine, a simple piston with a proven track record of over 200 years, which in turn drove a generator and continuously produced reliable electricity. To protect the base from the reactor's radiation, the solution was elegant in its simplicity. Dig a hole. The reactor was lowered into the Martian ground, using that same red soil as the primary shield. Buried beneath the sand, connected to the base through transmission lines, the atomic core began pulsing in a steady rhythm, 24 hours a day, 7 days a week, immune to any storm. Solar power during the day, nuclear power at night. A hybrid electrical grid, the backbone of the first city on Mars. With the energy problem solved, the real work could begin. And the real work meant confronting the greatest obstacle of all. The surface of Mars is a death zone. Without a planetary magnetic field, the surface is constantly bombarded by solar radiation. Temperature swings are extreme, sharp drops happening every single day. Permanent life on the surface without additional protection was impossible. the only way to build a safe and livable city was to go underground. The third spacecraft brought the answer, a next-generation boring machine designed and built by artificial intelligence to drill through Martian rock. This wasn't just a giant drill, it was an underground factory on wheels capable of digging, clearing debris, and constructing finished tunnels in one single continuous process. The machine was assembled and positioned in a trench, and then the main event began. Drilling on Mars presented unique challenges. Low gravity made it difficult to stabilize the machine, so it used hydraulic clamps to brace against the tunnel walls as it moved forward. At the front, the cutting head broke apart the rock. At the back, an automated train continuously cleared the excavated debris, and that debris wasn't simply discarded. It was sent to an above-ground concrete plant, where the excavated rock was processed and used to manufacture the tunnel wall segments themselves. A robotic arm installed those segments as the machine advanced, leaving a finished tunnel in its wake. What was dug out became the support structure. Mars was building Mars. Progress was continuous, but a concrete tunnel isn't fully airtight. Creating a breathable environment required a perfect seal. The solution was a two-part epoxy resin mixed with Martian dust, which expanded like foam, filling every microscopic crack. Applied as a spray-on layer, it sealed every joint and every gap, creating a completely airtight environment. For the first time on Mars, there was a livable space. The tunnels were the streets. But a city needs open spaces. The boring machine carved out spacious underground caverns, the future living quarters, laboratories, and common areas of the base. A constantly expanding network of corridors and rooms took shape beneath the red sand. The project followed a redundancy principle. If one tunnel was cut off, there were always at least two alternative routes between any 2 points in the city. On the surface, almost nothing had changed. The true scale of this construction project was completely hidden from view. Once the air systems came online and the interiors began to take shape, the next challenge emerged: life itself. The fourth spacecraft didn't bring construction workers. It brought the tools to create life. A chemical plant designed to transform Mars's dead environment into the basic building blocks of civilization. The first component was water. There was no liquid water on the surface, but there was ice buried several meters beneath the dust. A probe drilled its way down to an ancient and vast frozen water glacier. The ice was melted and pumped up to the surface. For the first time on Mars, liquid water flowed. The second component was the Martian atmosphere itself. A massive compressor froze carbon dioxide directly from the planet's thin atmosphere. With water and energy available, the first miracle became possible: electrolysis. An electric current split water molecules into their components: breathable oxygen and hydrogen. The oxygen was captured and stored for future colonists. The hydrogen was directed toward the second miracle, the Sabatier reaction, a chemical process with over a century of history, adapted for Mars. By combining hydrogen and carbon dioxide, the reaction produced two things: additional water and methane is rocket fuel, the exact fuel the spacecraft used for landing. The plant was producing fuel for the return trip to Earth, a spacecraft refueled on another planet. Energy, shelter, air, and water, the four pillars of survival, all produced on site. from Mars's own resources. With these systems up and running, the final piece of the life support puzzle could be built: the agricultural fields. The first seeds were sown in an underground garden, lit by artificial light and powered by nuclear energy. And life found a way. The first harvest on Mars grew beneath the red sand. A fully self-sufficient ecosystem began to breathe. The plant also produced nitrogen, a critical component of the fertilizers needed for the agricultural fields. Nothing was wasted. A completely closed-loop agricultural system. What came out of that plant wasn't just fuel. Food came out of it too. And that distinction was what separated a temporary outpost from a permanent city. When the city was complete and the army of robots rested after their great mission, a new countdown began back on Earth. The cargo of the next spacecraft wasn't equipment, it was people, the first colonists. Ready for a 7-month journey between two worlds, ready for a city that had been built for them, by machines, but for human beings. The final landing, touchdown, and then the first human steps, not just on Mars, but inside the city, moving toward the airlock, crossing through a door into a new civilization. Pressure equalization. The inner door opens. On the other side, clean, pressurized corridors. Green agricultural fields lit by an artificial sun. Running water. Fresh air. Home. The first city on Mars was not built by human hands. It was built by an army of robots, a testament to human ingenuity pushed to its absolute limits, forged in red dust, powered by dreams and sustained by science. It represents something that goes far beyond technology. It represents proof that humanity is capable of making a home where before there was only emptiness. If you want to keep learning about what gets built next, subscribe to this channel right now and hit the like button. Every notification is one more step on this journey.